now. Entire screen. Okay. So today we'll discuss the topics of the electrochemistry. So this is a very important section. I think many people have doubt. So I will just cover this section. Just a second. Just okay. All right. So I think the screen is visible, right? Please let me know, anyone. Yeah, it's visible. Perfect. Okay. So electrochemistry. So now, first of all, when we are starting with the electrochemistry portion, we need to know have a brief understanding what are the cathodes and what are the anodes, right? So in this electrochemistry, we will learn about three important major topics. So one will be the electrolysis. There are certain kind of questions they ask from the electrolysis section, from the electrochemical cells. Okay. So I think all of you have chemistry in your plus two level. So I will not go into the basics. I will just go in a revision mode like that I did in the organic chemistry section. And conductance. So you need to know only the important sections and the important formulas. By that you will be able to answer each and every questions from the electrochemistry chapter. First of all, you need to know that electrolysis means, so by the help of electrolysis we can actually make water by the hydrogen and the oxygen. We know these kind of things, but we are not concerning about that. We need to know that first of all, that in case of the electrolysis, okay, in case of the electrolysis, the negative electrode is known as the cathode. In case of the electrolysis, in case of the electrochemical cells, it will differ. I will say that after a few minutes. So in case of the electrolysis, the negative electrode is cathode and the positive electrode is your anode. Okay. Now in the cathode, cathode, okay, the cation will move, and in the anode the anions will move. You have a basic idea regarding this, but the trick here, you have to remember one thing, and I will solve some questions regarding this. That suppose if there is a particular uh, solution like dilute NaCl, okay, or if you have a concentrated NaCl solution, please be with me for a few minutes, then you will understand all the things which I'm trying to explain. So in an electrolysis cathode and electrolysis anode, you need to know, suppose if you give a solution, which ions will move towards which electrode. So the trick you need to remember for electrolysis, that always, always less less electropositive cation, less electropositive cation will move towards the cathode, towards the cathode, and more concentrated, more concentrated negative ion, negative ion will move towards the anode, will move towards the anode. So suppose this is the cathode and this is the anode, suppose. Okay. Now if you give a NaCl solution, dilute means there are also H2O. H2O means H plus and OH minus. NaCl means Na plus and Cl minus. And dilute solution means the OH minus level and H plus levels are very high. Okay. Now, which ion will go to the cathode and which ion will go to the anode? So, I have mentioned that over here that always the less electropositive cation will move towards the cathode. Now, you tell me among this sodium plus and among this H plus, which one is more electropositive? Tell me in the chat box. Which one is more electropositive among Na plus and H plus? As per the periodic table, here there is H plus, here there is Na plus. So this is more electropositive. Now, according to the trick, less electropositive cation will move towards the cathode. So in this cathode, this less electropositive cation means the Na plus will move towards the cathode, and more concentrated negative ions. So there are two negative ions, this Cl minus and this OH minus. Now, which negative ion is higher in number? More concentrated means higher in number. OH, because it is a dilute NaCl. Now, OH will move towards the anode. This is the basic understanding. Now, suppose if you have this condition, suppose this is the cathode and this is the anode, and if they give you that concentrated NaCl solution, concentrated means that H plus and OH minus levels are very very less, whereas the Na plus and Cl minus levels are high. Among these Na plus and H plus, less electropositive cation is also always Na plus among H plus and Na plus. So here in the cathode, Na plus will go. But now, as it is a concentrated NaCl solution, the OH minus level is very less. With respect to that, the Cl minus level is more concentrated than the OH minus. So here, the Cl minus and will go to the anode. The Cl minus will go to the anode. Now, as the cathode is negative, cation will come to the cathode. As the anode is positive, anion will attract towards the anode. Up to this, any doubt? Please let me know in the chat box. Is it clear or not? Clear up to this? Just let me know. Perfect. Now, this is the first trick. Now, trick number 2. Suppose if there is a metal in the salt, suppose when metal in salt and metal in the electrode are different, then the movement of cations and anions will be as per trick 1. What is the trick 1? Less electropositive cation will move towards the cathode, more concentrated anion will move towards the anode. But if the metal in the salt, if the metal in the salt and the metal in the electrode are same, then cathode will follow the same rule, will follow the same rule, but at anode, no anion, no anion will move, and hence the electrode will be destroyed by giving up electrons. Now what is the explanation of this? See this very carefully. Suppose in this previous case, suppose if I am taking this color, suppose for this case, suppose if you have this cathode and this anode, and suppose these are platinum electrodes, these the metal in the electrodes are platinum, and you have given a Na plus and Cl solution concentrated. So the metal, the sodium and the platinum, these are the different metal ions, right? So if the metals in the salt, metals in the salt and the metals in the electrodes are the different, then it will follow the trick one. So as it is concentrated, here the Cl minus will come, not OH minus, and Na plus and H plus may kaun sa, I think which one is less electropositive? Na plus. So Na plus will come. Now suppose if you have the case like suppose if you have NiSO4. Now this case, suppose if you have NiSO4 and the electrode is also nickel electrode, okay, nickel electrode. So now, okay, one second, just one second. I'm really sorry. I just gave you a wrong information. I'm really sorry. Among Na plus and H plus, okay, H plus is less electropositive. Please correct. Please make the correction. So less electropositive will be H plus because metals are more electropositive. Metals are more electropositive than H plus. Okay, please make this correction. I just did. I think I just gave you the wrong information. Okay, so among this Na plus and among this H plus, Na plus is metals are more electropositive, so H plus will come and bind with the electrode. The trick is correct. The trick is correct. Okay, so as per this, so among Na plus and H plus is less electropositive. It will come and bind up to TK. No problem. So suppose if you have a dilute this solution NaSO4 solution, it means we also have this H plus and OH minus. Now see this very carefully. Suppose here the cathode is made up of nickel. Here the cathode is made up of nickel. Okay. Now the point here is you need to remember one thing, that among nickel is also a metal and H plus is also a metal. So this is less electropositive. The cathode will follow the same rule. So it will come and bind over here. Sorry, nickel is a metal, so it's more electropositive. H plus is less electropositive, so H plus will come and bind over here. But in the anode, it is also made up of nickel. And the solution, as the metal in the salt and the metal in the electrodes are same, what will happen that in the anode it will actually lose electron. It will lose electron and it will become Ni2 plus. Okay, and you will see the concentration of the ions in the solution will increase, so the electrode will be destroyed, means the electrode will be corroded by giving up electrons. So you will see the concentration of the ions will increase in the solution. So let me give you another example. Suppose if you have suppose if the salt is MnSO4, manganese sulfate. Now suppose manganese in case of manganese sulfate, suppose that the electrodes are also Mn. So we'll also have water because it is a solution, because if you add this salt in the water then you will get a salt solution, means you also have water, means H plus and OH minus. Suppose now here Mn is a metal, H plus is not a metal, so it is more electropositive, it is less electropositive. So less electropositive cation will come and bind over here. But as the metal in the salt and the metal in the electrodes are same, here it will not follow the same principles like the more concentrated anion will come. No, as the same metals are present, this from this Mn, it will lose electron and it will become Mn2 plus. Now you will see that you are getting ions. So these metals from this Mn electrodes, manganese will be converted to manganese ions and it will release electrons. And you will see in this total solution, the concentration of the ions, concentration of Mn2 plus, it will start to increase. Why? Because it is now corroding from the electrodes. So two important tricks. Now suppose if the electrode is not made up of manganese, suppose it is a nickel electrode, then what will happen? Same H plus will come and bind over here, and as it is, suppose if it is a dilute solution, then more concentrated anion will be OH minus. OH minus will come and bind, and if it is a concentrated solution, then sulfate ion will come and bind. Is it clear, everyone? What I told you? Please let me know. Is it clear or not? So there are two important things: whether the electrode is made up of the same metal or not. If it is of the different metal, then the trick one. If it is of the same metal, then trick two, that cathode will be follow the same like that of the trick one, but for the anode, the electrode will lose electrons, and as a result of that, the concentration of the solution will increase because the ions are now being corroded out from the electrode. Clear up to this? Okay, so now let's move on to the next section. Another important formula you need to remember, that total charge on any ion, total charge in any ion will be equals to the valency of that ion into F. F stands for Faraday. F stands for Faraday. Faraday is 96,500 coulomb. It is the value of Faraday. So suppose if you have PO4 3 minus, what will be the total charge? So the valency is 3 into F. Total charge will be 3 into 96,500 coulomb. You will get the answer. Okay. Now if they ask you total charge in any one ion, so it will be valency into the F, total charge, but in one ion, so you just divide by the Avogadro number. Avogadro number. This is also an important formula, and this is also an important formula. These things are important. Cool. Now, what is Faraday? Now, what is Faraday? So, Faraday. See this very carefully. One Faraday amount of electricity, when passed through any electrolyte, through any electrolyte, then always 1 gram equivalent, then always 1 gram equivalent of gram, sorry, through any electrolyte, then always 1 gram equivalent of substance will be deposited, or liberated. If it's a solid, it will be deposited, or if it's a gas, it will be liberated. See this very carefully. Suppose if you give 1 Faraday amount of electricity, so you will get a deposition of 1 gram equivalent weight. Now, equivalent weight is nothing but the atomic weight by the valency. E is equals to the equivalent weight, A is the atomic weight. Okay. So suppose if you give 1 Faraday amount of electricity, okay, so always get 1 gram equivalent deposition. Okay, so molecular weight by its valency, that will be also the case. Now, another important trick. Trick 3. 1 mole of electrons. 1 mole of electrons always carry 1 Faraday amount of charge. For example, suppose if you want to convert Fe2 plus minus Fe2 plus minus E, that is Fe3 plus. So in this reaction, how many Faraday amount of charge? So there is 1 mole of 1 mole of electrons are being dissociated. So the charge will be 1 Faraday. If they ask you this kind of questions, so you can answer from here as well. Okay. So let's do some numericals. Then you will understand all the concepts. Okay. So type 1 numerical. Suppose if they give you that 1 mole of water on electrolysis liberate total amount of its oxygen. Total amount of its oxygen. Find out how many electricity is required. How many electricity is required. So how will you do it? See this very carefully. I will give you some examples so that you will easily understand. So from H2O, you are getting total oxygen. Total amount of oxygen is being released. So half O2 you are getting. Simple. So half O2 means 16 into 32. Half of that means 16 gram. 16 gram. Okay. Now we have studied that if you give 1 Faraday of amount of electricity, you will get 1 gram equivalent weight. For oxygen, the gram equivalent weight is 16 by 2, as the valency is of oxygen is 2. Atomic weight is 16, so it will be 8 gram. So 1 Faraday may you will get 8 gram of oxygen. You are getting 16 gram of oxygen from this water. How many Faraday? So it means 2 Faraday. It means 2 Faraday. 1 gram equivalent weight means 8. So 1 Faraday say 8 gram of oxygen can be liberated. So 16 gram के लिए how many amounts of Faraday current is required? 2F. You can do it in this way also. Suppose if you have H2O and if you actually do the reaction, okay, so you need 2H plus and you have to balance that, you need 2E minus. And 2E minus means 2 moles of electrons. 2 moles of electrons means 2 Faraday. Because 1 mole of electrons gives 1 Faraday. 2 moles of electrons means 2 Faraday. So the answer will be 2 Faraday amount of electricity is required. Type number 1 problem. Next type. Type 2. Suppose when 96.5 ampere current is passed for 10 minutes, then 3 gram of bivalent substance. Bivalent substance means valence equals to 2 is deposited. Okay, find the atomic weight of the substance. Okay, in question it is given that 96.5 ampere of current. We know that charge equals to current into time. We know that, or current equals to charge by time. So current into time is equals to charge. First of all, we'll calculate the charge. So 96.5 current into 10 minutes converted into second, that is the total amount of charge, that is that coulomb amount of charge has been provided. Okay, and this gives 3 gram of the bivalent substrate. Okay, so this amount of charge will give 3 gram. One 1 coulomb of charge will give 3 by 96.5 into 10. So I will just write 965 into 60, or I can write also 9650 into 6 gram. So 1 Faraday means 96,500 coulomb. That is 1 Faraday. It will give 3 by 9650 into 6 into 96500, 30. Okay, 9. Okay, it is not 96.5, it will be 9.65. Then the answer will be matched. 9.65. So it will be 965 into 6. So you will get 300 by 6, 50 will be the gram. We know, see this very carefully. We know that from 1 Faraday you get 1 gram equivalent. So this 50 gram is the 1 gram equivalent weight, or it is nothing but the equivalent weight. Equivalent weight is equals to atomic weight by valency. Valency is 2. Atomic weight will be equivalent weight into valency. 50 is the equivalent weight we have got from 1 Faraday, into valency will be 2. 100 gram will be the 100 gram will be the atomic weight. Is it clear, everyone? Please let me know. Fatafat. Is it clear or not? It's clear, right? Okay. And third type of question they can ask from electrolysis, that suppose if they give you a question like permanganate solution, if it's okay, then you can attend these kind of questions. Permanganate solution, but questions from electrolysis is very rare. They will ask questions from the conductance as well as from the electrochemical cells, which will go after this question. Permanganate solution in acidic medium reduces MnCl2 by electrolysis. How many how many how many Faraday of electricity is required? So in the question that it is in acidic medium, so MnO4 is the permanganate solution, MnO4 minus. In presence of H plus, you will get Mn2 plus. So if you balance that, you will get about 5 electrons, and 5 electrons means 5 Faraday. Same thing, it's just a balancing reaction. If you balance that, MnO4 minus 4O, 4 means 4H2O will give 4H2O means, so how will you balance? I will just give you a bit hint. I know that you know, but MnO4 minus, say you are getting MnCl2 means Mn2 plus. Okay, so MnO4 minus, here the charge is Mn2 plus. Okay, this is a reduction reactions. Now what is happening, there are 4 oxygen. Okay, so you will just write 4H2O, 4H2, 4 oxygen mil gaya, but there is 8 H plus, 4 into 2 8, so you will just write 8 H plus. Okay, now you see the charge difference. So there is plus 8 minus 1 means plus 7. Okay, and here there is plus 2. So if you add 5 negative, it will be balanced. So plus 5 electrons, 5 negative. 5 electrons are used means 5 moles of electrons means 5 Faraday is the amount of current. Is the amount of current. So these kind of questions you can expect from the electrolysis part. So is it clear everyone regarding the electrolysis? Then we'll move on to the electrochemical cell. Just let me know, is it clear or not? Okay. So now we'll move on to the electrochemical cell. From this section, maximum questions will come. Electrochemical cell. So first of all, we need to understand what is the difference between electrolytic cell and electrochemical cells. So here you write electrolytic cell, and here you write electrochemical cell. Okay, so first of all, in case of the electrolytic cell, we'll just see the differences. So now in case of the electrolytic cell, okay, in case of the electrolytic cell, electrical energy electrical energy is converted to chemical energy. Electrical energy is converted to chemical energy, whereas in the electrochemical cell, chemical energy chemical energy is converted to electrical energy. Point number one. Second point, in case of the electrolytic cells, which I have mentioned in the previous part, here the cathode was a negative electrode and the anode is a positive electrode. But in case of the electrochemical cell, it is just reverse. The cathode is positive because positive charges are actually binding and making it positive, and anode is negative. This is a very important thing. Now in electrochemical cells, as the anode is negative, okay, so see this very carefully. Okay, as the anode is negative, it will give off electrons. So please write it down, these points are really important. So note, in electrochemical cells, okay, since anode is negative, negative means how it became negative. So it became negative by giving up electrons. So it give up electrons. So it give up electrons. Anode is negative, too much negative. So it will give off electrons to get stability, right? So giving off electron means oxidation. So oxidation takes place at the anode. Oxidation takes place at anode. And this anode is always present at the left hand side of the electrochemical cell. Left hand side of the electrochemical cell. Whereas since the cathode is positive, it will gain electron to make it stabilized. So it accepts electrons. It accepts electrons. Acceptance of the electron means reduction is taking place in the cathode, at cathode, and it is present at the right hand side of the electrochemical cell. Okay, so if you draw just a figure, then you will understand this. Suppose, one second. Hmm, suppose this is the, these are the cases, these are the solutions where cathodes and anodes are present. Okay, so now just, yeah, so here and suppose in the left hand side, which one will be present? In the left hand side, the anodic solutions will be present. So in this left hand side, okay, so you will see the solution will be the anodic solution. Anodic solution. Okay, anodic salt solution. Salt solution. On the right hand side, the, so there will be cathodic salt solution. This is the cathodic salt solution. Salt solution. And in between the cathode and the anode, there is another kind of a structure. There is another kind of a structure. Sorry. There is another kind of a structure. Okay. This structure, this structure is known as the salt bridge. This structure is known as the salt bridge. In this salt bridge, okay, in the salt bridge, so there are different salts present. Which salts are present over here? So this is the salt bridge. So it actually gets dipped into this. So here, three types of salts are present: KCl or KNO3 or NH4NO3. These three types of salts are present in the salt bridge, and this salt is present in, this salt is present in gelatin. You don't need to remember all these things. Just I'm telling you. Or agar agar solvent. Agar agar solvent. Gelatin or agar agar solvent. Okay. Now, as this one is the, sorry, not this one. This is the salt bridge. This is the salt bridge. As this anodic solution, here the anode is negative, means it will lose electrons. So oxidation, this half of the cell is known as the oxidation half. Whereas this cathodic part is the cathode. So it is positive. As it is positive, it will gain electron. So it means reduction. So this half of the cell is known as the reduction half of the electrochemical cell. Okay. Now you need to remember one important point, that what is the function of this salt bridge? Why this salt bridge is so important? This salt bridge is important because they have three important functions. And what are the functions of them? Okay. So just write it down over here that first point, it connects the two half cell. So this is one half cell, reduction half cell, and this is the oxidation half cell. So first point regarding the function of the salt bridge will be it connects the two half cell solutions and complete the circuit. So you can see that the circuit is now complete and complete the circuit. Second function is it helps to maintain the neutrality. It helps to maintain the neutrality, the neutrality of the two half cell solution of the two half cell solutions. So it's being neutral by supplying. So this very carefully by supplying respective ions respective ions to the half cells. Suppose as this is a cathodic solution, it becomes so much positive, so it will give the negative ions like NO3 minus, Cl minus. So it becomes stabilized. On the other hand, this is too much negative, so it will give K plus, NH4 plus, so that the two solutions become neutral at the end of the time. And why these three salts are selected? Why these three salts are selected? Why KCl? Why KNO3? And why NH4NO3? Why these three salts? These three salts because why these three salts? Because the answer will be these three salts they have same mobility. They have same mobility. They have same mobility for cations and anions, and hence they actually maintain the neutrality. They actually maintain the neutrality. They maintain the neutrality. This is an important point. So it was all regarding the structure. Now let's move on to the another how this representation, how this cell representation is being done. So now we'll study about the cell representation. Cell representation. Now, first of all, if you have a reaction like suppose A plus, hmm, sorry, A plus no, A, B plus, okay, then A plus, B. So A to A plus, it is minus electron. Minus electron means it's an oxidation. B plus to B plus electron means reduction. Now, on the left hand side, there will be the anode or anodic metal and the anodic solution. Then there will be this one. This is nothing but this is the salt bridge. This is the representation of the salt bridge. And then you have your cathodic solution, cathodic salt solution, or might you also have the cathode metal. So that is the total representation. Now we know that the anode will have the oxidation part and the cathode will have the reduction part. So anodic metal. So here this A is the metal, it has oxidized and it becomes the ion and it's salt. So and this is the oxidation part. So the oxidation parts always comes in the anode. So it will be represented like A plus. Okay, metal and it's salt bridge, and this is the oxidation part. It has been oxidized, and then the cathodic portion B plus B. B plus to B is the reduction portion. B plus to B is the reduction portion. Is it clear everyone up to this? So this is the representation. Suppose if they give you a question like this, suppose if they give you a reaction, suppose like this kind of reaction, if they give, suppose they give you Zn plus Cu2 plus, okay, Zn2 plus Cu. So first of all, see Zn to Zn2 plus, it is the oxidation. Cu plus to Cu is the reduction. So oxidation half means it will be in the anode portion. So it will be Zn Zn2 plus, salt bridge, Cu2 plus, then Cu. That is the cell representation. Okay. Now let's move on to the next part. That is the electrode potential. From here, the questions and the numericals actually they're formed. So the next portion is the electrode potential. Now, in case of the electrode potential, just write these things. So I will just make you write in such a way that if you see the notes, that is enough. Half an hour will be the revision part. So electrode potential, it is actually the tendency of an electrode. It is the tendency of an electrode to give up or accept electrons. That is called the potential. So it means I have the potential to study, but I don't study, but I have the tendency to study, but I don't study, or I study. So it is also have the tendency to give up or accept electrons. That is called the potential. Accept electrons, not electrode. Accept electrons. Accept electrons. Now, the tendency to give up, the tendency to give up electrons, give up electrons, give up electron means oxidation. So this potential will be the oxidation potential. It will be the oxidation potential. Whereas the tendency to accept electrons, it will be the reduction potential. And this reduction potential is actually very important. Okay, maximum questions you can solve by uh, reduction potential. Okay, now this electron potential, it depends on what are they. First, it will depend upon the nature of the metal used at the electrode. Nature of the metal used at the electrode or used in electrode. And second, it will also depend upon the concentration of the ionic solution. It will also depend upon the concentration of the ionic solution. So obviously if you change the concentration, it will obviously change the tendency of change, because we know that concentration's affinity, you have an actual relation. So if you increase more amount of concentration, so if you increase the concentration of NaCl, it's concentrated NaCl solution and dilute NaCl solution, the nature of affinity will be different, right? Now just remember this thing: reduction potential is directly proportional to the concentration, whereas oxidation potential is directly inversely proportional to the concentration. We will try to solve all the questions. We'll try to solve all the question by the help of this reduction potential. Okay, we'll convert oxidation potential to reduction potential. So suppose if you have an oxidation potential of plus zero point 0.5 millivolt, its reduction potential will be the same value, but the sign will differ. So just the opposite sign will be its reduction potential. We'll solve all the questions by the help of reduction potential. That will be best. And also this electrode potential also depends upon, third will be, it also depends upon the temperature. If you change the temperature, the potential will also change. Now let's move on to the next one. Hmm. Now see this very carefully. Suppose, how will you calculate the EMF or E cell of a reaction? How to calculate that? So it will be E of cathode, electrode potential at the cathode, minus electrode potential of the anode. Okay, or you can write cathode is present on the right side, so E right minus E left. But I will give you a good trick. Please remember this trick, you won't regret. Suppose if in any problem, if they ask you this question, because in this in jam they will ask one question from this EMF. Okay, if in any problem oxidation potential is given, so you will understand. Suppose if they will give you a potential like this, Zn2 Zn2 plus, it means this to this means it is oxidation, and suppose this value is 0.25, so this value is the oxidation potential. And if they give like 2 plus to Cu, so it is gaining electrons. So if they give you this value, it means this is the reduction potential, this is the oxidation potential. So see this area, you can understand whether you are given with the oxidation potential or the reduction potential. Now my point is that if they give you in the problem, if they give the oxidation potential, if the oxidation potential is given, if the oxidation potential is given, then convert it into the reduction potential. What? Then convert it into reduction potential. You convert that into the reduction potential. How will you convert it? Just by changing its sign. Just bracket में, changing just by changing its sign, the value will remain the same. Okay, because the value of oxidation and reduction potential, because the value of oxidation and reduction potential of a particular potential, okay, they are always same but opposite in sign, but opposite in sign. So you have converted, suppose there is one reduction potential given and one oxidation potential given in the cathode and anode. Now what will be the trick is you calculate the E cell or the EMF, E larger amount minus E smaller amount. Larger amount or larger value minus smaller value. This is a very good trick. Okay, so this is a very important trick. Okay, I will show you with numericals, so don't worry about it. Okay, so this is an important trick. Other things I would like to mention, then I will solve you 7 types of problems from this electrochemical cell. Now there are certain conditions for a standard potential. We have studied in thermodynamics that we have standard value of the G, delta G 0. So there we will also have delta G, E cell, E0 cell. Okay, so conditions for standard potential, you need to have some standard. So for that, the solution of the half cell should be 1 molar concentration. Okay, and the pressure should be 1 atm, and the temperature should be 298 Kelvin. Okay, for standard hydrogen electrode, if the electrode is made up of hydrogen electrode, okay, the value of the standard hydrogen electrode potential is 0. It is 0. Okay, for hydrogen it is the standard electron potential E0 value is 0. Okay, now there is another kind of equation, in case of these electrochemical cells, and that equation is really important because they will ask questions from these equations as well. That equation is known as the Nernst equation. It is the Nernst equation. So in this Nernst equation, this equation actually indicates how the electrode potential depends or varies with the concentration, with the concentration of the ionic solutions and temperature of the ionic solutions. So what is the relation between the concentration of the ionic solutions with the electrode potential as well as with the temperature? So ionic solutions and temperature. So you know the, so for any kind of reduction reaction, suppose if you have any kind of reduction reactions like m n plus, you give that n amount of electrons and you will get m. It will now get precipitated. So it's not a ion right now. So we know the equation is E cell is equals to E0 cell minus RT by NF. F stands for Faraday. Natural logarithm M by Mn plus. Or if you have a complete reaction, for complete reaction, it will be E cell equals to E0 cell, E cell equals to E0 cell minus RT by NF ln anodic solution or anodic concentration. This is very important, by cathodic concentration. So you will be able to judge which one is anode and which one is cathode. Means oxidation jahan par ho raha hai, that is anode, and where there is reduction, that is the cathode part. That's fine. And then you just give that molar amount of this concentration and you will get the value. R is the Rydberg's gas constant, T is the 298 Kelvin, oh, sorry, 298 Kelvin, and this is the value of the, what amount of electrons has been changing, which electrons. Suppose this is Zn2 plus Cu2 plus and Zn. So this is 1 molar and this is 2 molar. Okay, so Zn2 plus to Zn, this is the reduction, and Cu2 plus is the oxidation. So here you will give 1, here you will give 2, n value will be 2 electrons. So this will be 2 electrons. You know all the value. They will give you the E0 cell value. You will have to calculate the E cell amount. Bas. But now let's make it more easier for the numericals. You don't have to give all the values. See this very carefully. For numericals, you need to remember this one, just derived form. So okay, do it like this. So this is m by mn plus. Okay, you just reverse it. So E cell equals to E0 cell, okay, plus 2.303. We want to give it in a log 10, okay, logarithmic in 10 base. So 2.303 RT by NF. Plus means I have changed this order, log of Mn plus, because the concentration of the of a particular substrate, if it is not charged, it's not an ionic solution. So it's not an ion. So the its concentration will be 1. Now again, let's simplify it. So it's for a suppose we are considering for a reduction reaction. So this is for the reduction reactions. So now E0 cell, now remember this, it will be 0.059 if you give all the values by n. So RT by NF into 2.303 will give you the value of 0.059 by n, log of Mn plus. And if you want to have a equation for the complete reaction, then the simplified version of it will be E cell equals to E0 cell plus 0.059 by n log of, just have to reverse it because minus to plus हमने किया, cathode concentration by the anode concentration. And just remember this equation. That will be all. If you don't have to consider the anodes, just give 1 in the anodic portion, that will be enough. So just remember this equation. Sorry, remember this equation. This is a really important equation. Okay. Now, if you have a hydrogen electrode, if you have a hydrogen electrode, so hydrogen electrode means you will have H plus plus E and you will get H2. It will evolve. So for an hydrogen electrode, We know, we have studied that the E0 cell of an hydrogen electrode is 0. So the E cell value will be 0 plus 0.059. The amount of electron is 1 log. This one will be H plus and H2 will be 1 because it is not an ion now. So log H plus. So the value of the E0 cell for an hydrogen electrode, you just remember this 0.059 log H plus, or minus 0.059 minus log H plus equals to minus 0.059 into pH. Remember this one, that will be enough. Is it clear up to this? Please let me know. Is it clear up to this? Please let me know, is it clear or not? Is it clear, guys? Okay, very good. Right. So let's move on to the next part. Okay. So what are the applications? We'll list down the applications, and from these applications we will solve all the problems. Okay. So that will be, this is a very important chapter. So if I have doubts in this chapter, so clear it out. First of all, application 1 will be, we can find out the EMF by using the equation. We can find out the EMF by the equation EMF or E cell E, don't do cathode minus anode, E large minus E small. I will show you how will you do that. Okay, just write it down now. Second application, we can also compare, we can also compare the reactivity of different metals, of different metals, in bracket. Less reduction potential means, less reduction potential means it indicates more reactivity. Important point. Okay, this is important. Less reduction potential means more reactivity. Okay, next, third, whether any reaction will occur or not, or the spontaneity of the reaction. So we can also get an idea of the spontaneity of a reaction. How will we get this kind of spontaneity of a reaction? If we know that if delta G is negative, the reaction is spontaneous. We also know that. But if the E0 cell, not E0 cell, if the E cell is positive, then it also gives an idea that it is, the reaction is spontaneous. So if it's positive, then the reaction is spontaneous. If it's negative, then the reaction is not spontaneous. And if you calculate the delta G value from this E cell, you will also get the delta G value will become positive. So we'll see that we know a formula that delta G is equals to minus NFE E cell, right? So if it becomes negative, then this delta G becomes positive. It means the reaction is not spontaneous. Okay, so that is the case. So E cell, if it's positive, then the reaction is spontaneous. Okay, and fourth, one second. Right. So the fourth one will be whether hydrogen gas will be liberated or not. You will also get an idea of that as well. Whether the hydrogen gas will be liberated or not, you can also get an idea of that as well. How? Just write it down. So whether hydrogen gas will be liberated or not by the reaction with metal and the acid, by the reaction between metal and acid. So just remember, when the reduction potential when the reduction potential is negative, if the value is negative, it means the hydrogen gas will be liberated. We'll see the hydrogen gas will liberated. It will be liberated. So I think they won't ask any question from this point. Okay. Okay. They won't ask any question from here. But I'm just telling you, if they ask, so you will be able to answer. And the last application, we can also find the free energy. So you know that delta G0, if you want to calculate, so that will be minus NFe E0 cell. Okay. So it's just the opposite sign. N is the number of electrons and F is the Faraday. Now, if you want to know the relationship between, if you want to know the relationship between or the relation between EMF or E cell, EMF or E cell and the equilibrium constant and the equilibrium constant. Suppose there is a reaction. Suppose there is a reaction. Small a moles of capital A plus small b moles of capital B. Say we get small c moles of capital C and small d moles of capital D. As per the Nernst equation, we know that from the E cell we get the value of the ionic solution, and from that ionic concentration we can actually deduce the equilibrium constant. From the Nernst equation we can write E cell equals to E0 cell minus RT by NF ln product by substrate. So we'll write in this way, product and uske power mein the concentration small c capital D to the power D by capital A to the power A capital B to the power small b. This is the, and this is nothing but, this is nothing but the, this is nothing but the equilibrium constant. This is nothing but the equilibrium constant. We can write Keq or Kc also, they also give Kc. So this will be E0 cell minus RT by NF ln K equivalent equilibrium. We can also write it in this way, E0 cell minus RT by N, RT by F will be 0.059 by N ln K equivalent, log K equivalent, not ln, because it will be 2.303 will also be added log. This will be E cell. This is also an important equation. This is also a very important equation. Now suppose if there is an equilibrium. So at equilibrium, E0 cell value, standard value is 0. So then E cell is equals to 0 minus 0.059 by N log K equivalent. So E cell will equals to E cell, sorry, at equilibrium E0 cell, not E cell. E cell is 0. Like delta G is 0, at the same time E cell is also 0. Hmm. Excellent. Hmm. So E cell is 0. So this will be 0. E0 cell minus this. So the E0 cell value will be 0.059 by N log K equivalent. K. This is another equation. And now, so we have studied two important equations, delta Z0 equals to minus NF E0 cell. And we also studied E0 cell, E0 cell. Okay, we have also studied that E0 cell is equals to 0.059 by N log K equivalent. If you combine these two equations, you will get the value delta G0 equals to 2.303 RT log K equivalent. K equilibrium, sorry, equilibrium constant. So this is another important. So these three equations are really important for your numericals. Numericals say they can ask question is from these three equations. NFE cell 0.059 by N log K equilibrium and delta G0 equals to 2.303 RT log L log K equilibrium. Okay. Now you just understand another last concept, then we'll move on to the numericals. If, see this very carefully, if a reduction potential value is more, if reduction potential value is more, means it will be reduced, अपने आप से वो reduced हो जाएगा, self, so it will be self reduced. As it is self reduced, it means it will oxidize others, it will oxidize others, means oxidizing power is more. This is a very important concept. Okay, means suppose for a particular electrode, if the reduction potential is more, so that electrode will be reduced itself, but it will oxidize the other electrode, so the oxidizing power is more. So those electrode which have higher reduction potential, they also have higher oxidizing power, not oxidation potential, oxidizing power. Tendency to oxidize others is known as oxidizing power. Tendency to reduce itself is known as reduction potential. So more reduction potential means it is self reduced, will oxidize other, so the oxidizing power is more. And if the reduction potential value is less, it means it will be self oxidized, it will be self oxidized, it will reduce others, so the reducing power will be more, reducing power will be more. This is a very important concept. It's a very important concept. So up to this, anyone has any doubts, then I will move on to the numericals. Any doubts, please let me know. Is it clear up to this? Please let me know in the chat box. Okay. Others, please let me know. Good. So let's move on to the type of numericals. So type 1. First question. Suppose if E0 value Cu 2 plus 2 Cu is given 0.34 volt and E0 Ag to Ag plus it is given minus 0.80 volt. Find the EMF or E0 cell value of the reaction Ag plus plus Cu2 plus Ag. So the trick was EMF or E cell will be E large minus E small. But before that, if there is any oxidation potential given, convert it to reduction potential. You have two reduction potential, and now just subtract the smaller one from the larger one. Now, this one, Cu2 plus to Cu. Let me know in the chat box, is it oxidation or reduction? Cu2 plus to Cu. This potential is a oxidation potential or a reduction potential? Chat box में फटाफट. Is it a oxidation potential or a reduction potential? Cu2 plus से Cu हो रहा है. Reduction potential. So we don't need to change any reduction potential. Perfect. Now see this. This one Ag to Ag plus. Is it this value? This potential is an oxidation potential or a reduction potential? This one reduction potential or oxidation? Ag to Ag plus. It is oxidation potential. Perfect. So we have told you that if there is an oxidation potential, you convert it to reduction potential but just by changing its sign. So it will be now the reduction potential value will be plus 0.80 volt. So you have one reduction potential value 0.34 and you have another reduction potential of plus zero point 0.8. Now you subtract the smaller one from the larger one. This one is smaller, this one is larger. So 0.80 minus 0.34. The answer will be 0.46 volt. Done. You don't need to do any other things because in there are many other books that they will say cathode kar lo, anode kar lo, then cathode minus anode karke first of all nikalte hain. Don't do this. Any oxidation potential, convert it to reduction and then just subtract from the larger one, smaller one from the larger one. Okay, good. This is type 1 problem. Now you will answer this type of questions. This is a second type, but it is just a corollary of the first type. So type 2. Suppose for the following two half cell reactions, Zn, Zn2 plus, this is the reaction. They have already given this reaction, okay? And the value of this E0 is 0.76 volt. And Fe2, Fe2 plus 2E, the value is 0.41 volt. 0.41 volt. Okay. Find the EMF. Find the EMF of the reaction Zn plus Fe2 plus Zn2 plus Fe. Option 0.45, 0.30, 0.35, 0.40. Solve it and tell me the answer. See whether there is oxidation or reduction. If oxidation, convert it to reduction by changing the sign. Subtract the smaller one from the larger one, you will get the EMF. Done. See the two reactions, whether this is oxidation or reduction. If it's oxidation, change the sign, subtract, and you will get the value of the EMF. Let me know in the chat box what will be the answer. A, B, C, or D. I got one answer. Others, please let me know. I got Simran's answer, and then others. Perfect. So what is the thing? Here we are having these two reactions. This is all our oxidation reactions. So these are the oxidation potential. You just convert it into the reduction potential, minus 76 volt and minus 0.41 volts. Among them, which one is more or the larger value? This one is the larger value. So minus 0.41 minus 0.76. This will be the minus 0.41 minus 0.76. This will be plus. So this answer will be 0.35 volt. C answer. Good. This is a type 2 wala problem. Let's go to the type 3 wala problem. Type 3. Now, the question is, if the standard, not I'll not write this. Suppose if the E0 cell value of a reaction of the reaction Zn plus Cu2 plus Cu plus Zn2 plus, this is the reaction, is the E0 value is 1.10 volt. Okay, the E0 value is given. Find the cell potential. Find the cell potential means the E cell value when 0.1 molar of Cu2 plus ion and 0.01 molar of Zn2 plus ion are used are used in the half cell. Options are 1.03 volt, option 1.13 volt, option 2.03 volt, option D 2.13 volt. Solve it. Use nonce equation and you will get the answer. So that use that wala. E cell equal to E0 cell plus 0.059 by n log cathodic by log anodic. In the cathode, reduction was there. In the anode, yeah. So do it like that, you will get the answer. Cathodic by anodic. And see whether which one is the cathode half cell and which one is the anodic half cell. Where there is reduction, that is the cathodic half cell. Where there is oxidation, that is the anodic half cell. And then you will get the answer. Please let me know what will be the answer. You can use the calculators as well. In JAM, you will get calculators. Tell me what will be the answer. Okay, I got one answer. Others? Perfect. So B will be the correct answer. Why? See this very carefully. So here in this equation, Cu to Cu2 plus to Cu, this is the reduction. Means this is the cathode. And this Zn to Zn2 plus, it is the oxidation. That is the anode. So as per the Nernst equation, E cell is equals to E0 cell. We'll write the modified one, 0.059 by N is nothing but 2 electrons, 2 log of cathodic by anodic. So cathode वाला कौन सा है? Cu2 plus 2 Cu. This is the cathodic part. That is, sorry, 0.1 by anodic वाला Zn to Zn2 plus 0.01. So E0 cell value is 1.1 plus 0.59 का हम लिख सकते हैं 0.06 by 2 log 10. Log 10 value is 1. 1.1 plus 0.03 into 1. This will be 1.1 plus 0.03, 1.13, 1.13. Clear up to this? Now, suppose if they give you a question like this, let's go to another type. So, if you have understood this, so you can solve the questions now. Suppose they have given you a question like find type 4. Find the potential, find the potential of hydrogen electrode, H electrode लिख hydrogen electrode having pH of the solution equals to 10. Having 10 pH of the solution, what will be the potential of the hydrogen electrode? So this is a very straightforward question. So E cell will be equals to E0 cell plus 0.059 by N log, it will be H plus. Now first, the standard hydrogen electrode value is 0 for hydrogen electrodes. So E cell will be equals to 0.059, N is 1, log of H plus, give minus 0.059 into minus log of H plus is pH, minus 0.059 into pH is 10 minus 0.59 will be the potential. Simple question. Simple question. Okay. Type 5. Suppose they have given you E0 Ni to Ni2 plus. Okay, why minus? Why minus? Because minus log of H plus is equals to pH. Minus log of H plus is pH. So in order to get minus log H plus for the pH, so we are actually uh, multiplying minuses. So minus 0.059 into minus log H plus is nothing but this one. Minus minus में plus हो जाता है. But we are writing in 2 minus. So that we can write minus log H plus as pH. So this minus sign is now coming. Okay. Now the type 4. Type 5. Type 5 may, I think they have given you this case that E0 Ni2 Na2 plus, that is 0.25 volt, and E0 Cu2 plus, the value is minus 0.34 volt. Now see this very carefully. Okay, is it possible, is it possible to keep 1 molar CuSO4 solution in a nickel container, in a nickel container? Tell me, yes or no? What will be the answer? If you understand the concept, you can easily answer. Is it possible to keep or not possible to keep? See, this is a question. Reaction, is it possible to keep? If it's possible to keep means there should not be any reaction. There should not be any spontaneous reaction. If there is spontaneous reaction, it is not possible to keep. Now, just correlate the spontaneity of the reaction with the EMF or the E cell value. Then you will get it. You have two corresponding reduction potentials and or oxidation potentials. Calculate the EMF, and if you see the EMF is positive, then there will be reaction. The reaction will occur. So as reaction will occur, it is not possible to keep this CuSO4 solution in a nickel container. So now tell me, is it possible or not to keep CuSO4 solution in a nickel container? If the reaction will occur, it's not possible. If the reaction does not occur spontaneously, then it is possible to keep. Then what will be the answer? Yes or no? Is it possible to keep or not? Anyone? Anyone? No. Why not? Very good, would be. So first of all, Ni to Ni2 plus, Cu to Cu2 plus, all these are oxidation potential. So their reduction potential value will be 0 - 0.25 volt and minus and 0.34 volt. EMF value will be large minus lower. So 0.34 minus 0.25. It will be 0.34 plus 0.25. So means 9 and 5, 0.59. This value is positive. And if this value is positive means reaction will occur. Reaction will spontaneously occur. And if the reaction will spontaneously occur, it is not possible to keep this CuSO4 solution in a nickel container. So answer will be no. So these kind of questions you can expect from these electrochemical cells. Okay. Now let's move on to the last topic of today, that is the conductance. So there are two, three formulas and there is one law, that is enough. So now we are going to the conductance portion. Conductance. Now in case of the conductance, okay, we know that resistance is rho into L by A. This is the resistance. And this is the specific resistance or the resistivity. This is the length and this is the area of cross section. Conductance is just the reverse of resistance. Resistance will resist to flow. Conductance will allow to flow. Conduction. So conduction or conductance, sorry, conductance, we write conductance as lambda is 1 by R. And this rho is the resistivity or the specific resistance. So there is also specific conductance or the conductivity. We write capital L. Capital L is 1 by rho. This is the specific conductance or conductivity. Lambda, which is the conductance, there are two types of conductance can be there. One will be the molar conductance. One will be the molar conductance. We write it as lambda m. Another kind type of conductance will be equivalent conductance. Will be equivalent conductance, lambda eq. Okay. So let's first start with the molar conductance. Molar conductance. It is the conductance of a solution. Please write it down. It is the conductance of a solution containing 1 gram mole or the 1 molar or 1 molar of dissolved electrolyte placed between two electrodes which are 1 centimeter apart. This was the molar conductance. Equivalent conductance is just the same, but it consists of 1 gram equivalent of the dissolved electrolyte. So it is the conductance of a solution containing 1 gram equivalent or 1 normal of the dissolved electrolyte placed between two electrodes 1 centimeter apart. Same thing. Now, mathematically, mathematically, the molar conductance, you need to remember this formula. That's all. Lambda m is equals to 1000 into capital L, which is the specific conductance, by the concentration in moles. We can also write in that capital L by the molarity. Okay, in molarity. Now, for equivalent conductance, what will be the formula? For equivalent conductance, what will be the formula? So, for equivalent conductance, lambda EQ is equals to in C. That is a gram equivalent. It is the gram equivalent per liter. So we can write it 1000 into L by normality. Okay, that is the case. So these are the two equations you need to remember by heart. Okay, these are the important equations. Now comes an important law. This is a very important law. So the law is known as the Cole-Rach's law. Cole, this spelling is very tough. Cole, I think CH apostrophe S, like this. Please check it if the spelling is right or not. So it will be Cole-Rach's law. Cole-Rach's law. So there are three important laws. I will explain two and then third. First, with respect to equivalent conductance, with respect to equivalent conductance, there is a law. So the law is at infinite dilution, if you dilute infinitesimally, at infinite dilution, okay, the equivalent conductance of any, this one is important, weak electrolytic solution. It's not for strong. Okay, weak electrolytic solution is the equivalent conductance of any weak electrolytic solution is the sum of the equivalent conductance of the cation on the anion, the sum of the ionic conductance of cation and anion. So equivalent conductance will be the ionic conductance, and that is also the kind of the equivalent conductance of the cation and anion. They can also write in this way, of this cation and equivalent conductance of the anion. This is one law. Second, with respect to molar conductance, with respect to molar conductance, at infinite dilution, at infinite dilution, the molar conductance, the molar conductance of any weak electrolyte, of any weak electrolytic solution, of any weak electrolytic solution is the sum of the, is the sum of the ionic conductance, is sum, is the sum of the ionic conductance each multiplied each multiplied by number of ions present in the solution, by the number of ions present in the solution. I will explain you. Present in the solution, what it is saying. Suppose if you have this electrolyte, that AXBY, so it will dissociate in this form, right? The charge is this, and this valencies come from this charge, we know that. So it will be X amount of A having charge Y plus Y amount of B having charge X minus. That is the case. So for this is the ionic conductance of this, and this AY plus, and this is the ionic conductance for this Bx minus. So the lambda m will be xm plus y, sorry, this is, suppose this is n kar lo, n n n y, or y n, or mx plus ny. Number of the ions into its ionic conductance, number of the ions into its ionic conductance, that will give your molar conductance value. That will give your molar conductance value. Okay. So what is the application? What is the application of this Kohlrach's law? So we can find out, the application of this Kohlrach's law is that we can find out, one second guys, one second. Sorry. Yeah. So application of this Kohlrach's law is that we can find out the equivalent and the molar conductance of any weak electrolyte at infinite dilution. Please don't remember this infinite dilution. It's very important. Okay. So suppose if they give you a question like this, that um, suppose if they give you that the ionic conductance of AB, suppose it is given X, of BC is given Y, of CD is given Z. Find the find the conductance of the find the equivalent conductance find the equivalent conductance of AD. How will you do it? So we have studied in plus 2 level that divide it and do this. Just learn this trick. The trick will be, add that to what you want to need. So add those which is present in the, which you want, and subtract others. Means simple. AD, where there is A, there is A. Where there is D, there is D. So the equivalent conductance of AD will be, simply X plus Z minus Y. This will be the answer, because this one is the rest. You don't need that. Just subtract it. So now let me give you in a proper manner, proper numerical for this. So suppose in the question, if they give you a question like this, that the equivalent conductance at infinite dilution for NaCl, comma, NaOH, comma, NH4Cl are respectively Suppose 126.4, comma 248.1, comma 149.7. The unit is ohm inverse centimeter square. Centimeter square. Okay. Find the equivalent conductance. It is coming from the first law. Equivalent conductance is equals to the sum of the equivalent conductance of the ions. So find the equivalent conductance of, suppose they give you NH4OH. So here there is NH4 and there is OH. Find where there is NH4. Here there is NH4. Means this is the value. And where there is OH. Here there is OH. Means this is the value. So add these two, subtract this. So this will be 149.7 for NH4 plus for OH this will be 248.1 and just subtract the rest. This one is only the rest. 126.4. The value which will you get, that will be your answer. That will be your answer. Okay. Another important point, we can also, the second application is that we can also find out the degree of dissociation. So degree of dissociation you have studied in the ionic equilibrium alpha. Okay, degree of dissociation of any weak electrolyte, of any weak electrolyte. Hmm. So alpha will be the molar conductance at any given condition or any given concentration, sorry, by molar conductance at infinite dilution. So they will give you these two values. Don't worry. They will give you this molar conductance at this at a given concentration. They will give you the value, and they will also mention the molar conductance at infinite dilution. They will also give you the value. You just subtract, you just divide them, you will get the value. So from this alpha value you can also, H plus, we know that H plus equals to C alpha. From that you will get the concentration of the H plus, and if you want to know the pH, that will be minus log of H plus. So from that you can also get the pH value. Okay, so that is the case. So you can actually correlate this alpha to the ionic equilibrium questions. Now suppose we can also find the solubility of any weak electrolyte. Third will be the, we can also find out the solubility of any weak electrolyte. It's simple. Of any weak electrolyte. How? So we know that solubility is denoted in number of moles per liter, or it is nothing but the molarity. So we know that if we know delta M, we know this formula by molarity. So we can also write this as well, that this is also equals to 1000 into specific conductance by solubility as well. So if they give you question like this, don't get any tension. So the unit of them, molarity and solubility, are all molar. So S will be also in molarity. So we can also get the solubility. So if you want to get S, so the value will be 1000 into L by lambda m. That will be the solubility. And from this S, you can calculate the solubility product KSP with respect, that is a equation given in the ionic equilibrium. That is the just interlinking two topics. And the last point of today, last section, is that if you want to calculate the equivalent conductance, okay, so we have studied that molar conductance will do for AX and BY. You will give, if for this A it is M, any conductance, and if it is N, so the molar conductance will be M into the number of ions X plus N into the number of ion. But if you want to do the equivalent conductance, so this AXBY breaks into X AY plus Y B X minus. Equivalent conductance. And now suppose the ionic conductance of A and B are given same, M and N. This will be the value of the molar conductance. But for the equivalent conductance, it will be equivalent conductance at infinite dilution. Okay, so one other important thing, if they mention infinite dilution, then you will have a zero, lambda m zero. Lambda m zero will be given. So alpha will be equals to lambda m by lambda m zero. Then you will get the alpha. That zero wala thing, that is the infinite dilution wala thing. Now, for lambda equivalent at the infinite dilution, what will you do is that it will be the ionic conductance, but by the charge on that ion, y. Ionic conductance of B, N, by the charge on that ion, X. That will be answer. But in case of the molar conductance, the amount of the charge is X. Amount of that ion is Y. But in case of the equivalent conductance, the charge of that ion, Y, for M, for this A. And the charge of B is X. That's why this. So this will be another important case. This will be another important case. So that is the case. So if they give you questions like, if you have an ion called A2B3, okay, and the conductance of them is suppose 10 and suppose this is 20, so lambda m will be 20, or lambda m will be 2 into 20 plus 3 into 60. So 3 into 20, 2 into 10 and 3 into 20. So it will be 20 plus 60, 80. But if you do lambda equivalent at infinite dilution, so it will be A2 3 plus B 3 2 minus. So then it will be 10 by 3 plus 20 by 2. It will be 10 by 3 means suppose 3 point something, 3.3 plus 10, 13.3. The value will be totally changed. The value will be totally changed. So by this, we end this chapter. The total electrochemistry is now completed. So if you have any doubts, please let me know. Is it clear, everyone? Is it clear, everyone? So I have completed the entire electrochemistry section, electrolysis, electrochemical cell, as well as the conductance. Very good, very good. So again, we'll meet you in the next week. Okay, I think tomorrow is the next week. So we'll give some extra classes. So at Tuesday from 4 to 6, there will be a physics class on the optics. Okay, so just keep your I think Anirban sir will take the class. So the optics class will be on Tuesday. We'll also let you know if we schedule any extra classes as well. Okay, so that was all, guys. Thank you very much. We'll meet you in the next week. Bye bye.